Hi, welcome to my channel. This is Pushpita here. In this section, I wish to take a class 12 topic, the types of functions. Let's explore. In class 11, you have learned about some special functions like identity function, constant function, polynomial function, modulus function, signum functions and their graphs, and also addition, subtraction, multiplication and division of two functions. Let's extend our study about functions where we finished earlier. Let us recall what is a function. Function. Let A and B are two non-empty sets. A relation from A to B is called a function if every element of set A has one and only one image in set B. See the given mapping or arrow diagram. You can see that every element of set A is associated to a unique element in set B. So, it is a function. Let us study the types of functions. First one function or injective or injection. A function f from A to B is said to be one function if distinct elements of A has distinct images in B. See the mapping. Here, 1 is related to B, 2 is related to A and 3 is related to D. So, it is 1. Listen that C belongs to set B doesn't have a pre-image in set A, which doesn't matter. Now, let us check whether the graph of fx is equal to x square is 1 or not. You might be learned that the graph of fx is equal to x square is an upward parabola. How will you check whether it is 1 or not? Draw a line parallel to x-axis. Now you can see that the line intersects the parabola in two distinct points. That means the y-coordinates of both the points are same. So it is not 1. Now let us define one function. Definition. A function f from x to y is said to be a 1 or injective if the images of distinct elements of x under f are distinct. That is, for every x1, x2 belongs to x, fx1 is equal to fx2 implies x1 is equal to x2. Let's do some questions. Question 1. If A is equal to set 1, 2, 3, B is equal to set 4, 5, 6, 7 and F is equal to 1, 4, 2, 5, 3, 6 is a function from A to B. State whether F is 1 or not. See the question. Given that set A is equal to 1, 2, 3, B is equal to set 4, 5, 6, 7 and F from A to B is defined as F is equal to 1, 4, 2, 5, 3, 6. Now we get F1 is equal to 4, F2 is equal to 5, F3 is equal to 6. Since distinct elements of A has distinct images in B, the function is 1. See the next question. Show that the function f in A is equal to r minus set 2 by 3 defined as f of x is equal to 4x plus 3 by 6x minus 4 is 1. See the question. Given that fx is equal to 4x plus 3 by 6x minus 4. Now let x1, x2 element A. Now fx1 is equal to fx2, which implies to 4x1 plus 3 divided by 6x1 minus 4 is equal to 4x2 plus 3 divided by 6x2 minus 4. That is replacing x in fx with the x1 and x2. By cross multiplication we get 4x1 plus 3 into 6x2 minus 4 is equal to 4x2 plus 3 into 6x1 minus 4, which implies 24x1 x2 minus 16x1 plus 18x2 minus 12 is equal to 24x1 x2 minus 16x2 plus 18x1 minus 12. Now we get negative 34x1 is equal to negative 34x2, which implies to x1 is equal to x2. Therefore, f is 1, 1. See the next function. Many one function. A function f from a to b is said to be a many one function if two or more elements of set A have the same image in B. See the mapping. Here 1 and 2 shares the same image, hence it is many one. On-to or surjective or surjection. A function f from a to b is on-to if every element of set B has pre-images in set A. That is, range and codomain are same. See the mappings. First one, 1, 1 and on-to. Second one, many one and on-to. In first one, set B has 3 elements and each element is associated to unique element in A. Hence it is 1, 1 and on-to. In second mapping, you can see that each element in B is associated to elements in set A, that is 1, 1, and also B belongs to set B have 2 pre-images in set A, that is many one. Hence the mapping 2 is many one and on-to. Let us define on-to function. Definition. A function f from x to y is said to be on-to if every element of y is the image of some element of x under f. That is, for every y belongs to y, there exists an element x in x such that f of x is equal to y. Let's do. Question 1. Show that f from n to n is given by fx is equal to x plus 1 if x is odd, x minus 1 if x is even, is an on-to function. See the question. Given fx is equal to x plus 1 if x is odd, x minus 1 if x is even. Here n represent natural numbers. In order to show fx is on-to, we have to show that its range and codomain are same. Let's check. f1. Since 1 is odd, take x plus 1. We get f1 is equal to 1 plus 1 is equal to 2. f2. Since 2 is even, take x minus 1. Now f2 is equal to 2 minus 1 is equal to 1. Similarly, we get f3 is equal to 3 plus 1 is equal to 4. f4 is equal to 4 minus 1 is equal to 3, and so on. Now we get range of fx is equal to n. Also given that codomain is equal to n. Since range is equal to codomain, fx is on-to. See the next question. If A is equal to r minus set 3 and B is equal to r minus set 1, consider the function f from A to B defined by fx is equal to x minus 2 by x minus 3 for all x element A, then show that f is on-to. In order to show f is on-to, we must show that the range of fx and its codomain are same. Given A is equal to r minus set 3, B is equal to r minus set 1, fx is equal to x minus 2 by x minus 3 for all x element A. Let y is equal to x minus 2 by x minus 3. Now we get xy minus 3y is equal to x minus 2. That is, xy minus x is equal to 3y minus 2. X into y minus 1 is equal to 3y minus 2, which gives x is equal to 3y minus 2 divided by y minus 1. Therefore, x element r minus 3 for every y element r minus 1. Now, what does it mean x element r minus 3 and y element r minus 1. See, if we take x is equal to 3, we get y is equal to x minus 2 divided by 3 minus 3. That is equal to x minus 2 by 0. Since division by 0 is not possible, which is infinity. Similarly, if we take y is equal to 1, we get x is equal to 3y minus 2 by 0, which is also infinity. So, range of fx is equal to r minus 1. And also, codomain is fx is equal to r minus 1. Therefore, range is equal to codomain. Hence, fx is an onto function. Let's study the next function, 1, 1 and onto, or bijective or bijection. A function f from x to y is said to be 1, 1 and onto if f is both 1, 1 and onto. See the mapping. Different elements in A have different images in B. Therefore, 1, 1. Also, range is equal to codomain. Therefore, onto. Hence, it is bijective. Let's do some questions. Question 1. If A is equal to r minus set 2 and B is equal to r minus set 1, if f from A to B is a function defined by fx is equal to x minus 1 by x minus 2, then show that f is bijective. See the question given, fx is equal to x minus 1 by x minus 2 and f from A to B, where A is equal to r minus set 2 and B is equal to r minus set 1. If f is bijective, then it must be 1, 1 and onto. Let's check 1, 1. Let fx1 is equal to fx2 for every x1, x2 element A, which implies x1 minus 1 divided by x1 minus 2 is equal to x2 minus 1 by x2 minus 2. We get x1 minus 1 into x2 minus 2 is equal to x1 minus 2 into x2 minus 1. That means x1 x2 minus 2x1 minus x2 plus 2 is equal to x1 x2 minus x1 minus 2x2 plus 2, which implies to minus x1 is equal to minus x2. That means x1 is equal to x2. Since fx1 is equal to fx2, which implies x1 is equal to x2 for every x1 x2 element A. Therefore, fx is 1, 1. Onto. Let y is equal to x minus 1 by x minus 2, which implies xy minus 2y is equal to x minus 1. xy minus x is equal to 2y minus 1. That means x into y minus 1 is equal to 2y minus 1. That is x is equal to 2y minus 1 by y minus 1. So, the range of fx is equal to r minus 1. That means range is equal to codomain. Fx is onto. Since fx is 1, 1 and onto, fx is bijective. See the next question. If f from r to r is the function defined by fx is equal to 4x cube plus 7, then show that f is a bijection. Given f from r to r such that fx is equal to 4x cube plus 7. Here r represent real numbers, so you can consider both rational and irrational. To check 1, 1, let fx1 is equal to fx2 for every x1, x2 element r, which implies 4x1 cube plus 7 is equal to 4x2 cube plus 7. 4x1 cube minus 4x2 cube is equal to 0. That means x1 cube minus x2 cube is equal to 0. Let us recall the identity. A cube minus B cube is equal to A minus B into A square plus AB plus B square. Therefore, x1 minus x2 into x1 square plus x1 x2 plus x2 square is equal to 0, which implies x1 minus x2 is equal to 0 or x1 square plus x1 x2 plus x2 square is equal to 0. Since x1 x2 element are x1 square plus x1 x2 plus x2 square not equal to 0. Therefore, x1 minus x2 equals 0, which implies x1 is equal to x2 for every x1 x2 element R. Therefore, fx is 1 1. Check on 2. Here we have to show that range of fx is equal to codomain. Let us assume that y is equal to 4x cubed plus 7, which implies 4x cubed is equal to y minus 7. That means x cube is equal to y minus 7 by 4. Taking cube root, we get x is equal to y minus 7 by 4 the whole raised to 1 by 3. That is, for every y element R, we get x element R. Therefore, range of fx is equal to R. Since range of fx is equal to codomain of fx, fx is an onto function. Since fx is both 1 1 and onto, fx is a bijective. Let me wind up this topic. We'll meet in the next section. To get my next videos, please subscribe my channel. Thank you.